right. Hello, everyone, and welcome to this session, and welcome again to JiraCon23. My name is Connor Wolford, and I represent and work for Xray, which is a test management plugin for Jira. We are owned by a company called Idea, so that's why you're seeing that there. But today, we're going to be focusing on Xray and really honing in our skills on model-based test design and combinatorial testing. The name of this session is called Testing Smarter, Not Harder with Model-Based Test Design. And we're going to learn how we can really start to accomplish just that today. So again, my name is Connor Wolford. Really appreciate you attending today's session. And thank you again for joining JiraCon23. And a big shout out to Trundle for hosting this awesome event. So that being said, let's go ahead and get right started into today's session. So we're going to cover these topics today. I want to start off with one of our newer features, Test Case Designer, just a brief overview of it to really set the context and of what today's session is all about. So we're then going to get right into what is model-based testing and how do we implement it. From there, we're going to look at how Test Case Designer can help facilitate allowing us to achieve essentially more critical testing thoroughness and coverage, and doing so most of the time, if not every single time, with fewer tests. And then time permitting, I'll have time to show hopefully a couple extra Xray Enterprise features, which is one of our new products here, and we'll finish up with some Q&A. Again, that's me, Connor Wolford. I'm a senior partner manager here at Xray. So let's just dive right in. So what is Test Case Designer? Well, it's a solution that has been specifically built for Xray Enterprise. It's a test design optimization tool that will allow you essentially to achieve 100% coverage and do so in as fewer tests as possible. The tool exists to really eliminate gaps in coverage and turn test scenarios into automated test scripts really quickly. However, the tool can also be used for manual execution as well, I should mention. The tool will help you really find defects 2 times as faster than really kind of writing tests on your own or how you might be writing tests right now. And it's these tests that the tool is going to generate for you systematically cover 100% of all of the application's critical interactions using its algorithm. Last point I'll just mention, just to set the stage here about Test Case Designer, is that it enables you to really optimize your in-sprint automation. We'll see a little bit of how that starts to come to life today. We'll have trials available as well. You can check that out. We'll talk more about it. But the goal here with the in-sprint automation capabilities is allow you to essentially create clear and consistent steps really quickly that use a Gherkin syntax that aligns really well with behavior-driven developments as well. So that's what Test Case Designer is all about. Essentially, again, achieving more coverage with less, aka fewer tests. And we're going to see how the tool really allows you to approach all of this with a model-based approach. And then the tool's algorithm then is going to use that model to generate optimized test cases for us. So that's what Test Case Designer is all about. We'll see how it comes to life in a bit here and how we use these approaches inside the tool, but just using this slide to really set the stage here. Along with this slide, so the tool really exists because we do see these common pain points with our clients before they adopt the approaches that you'll see today inside Test Case Designer. So they're still using outdated approaches for designing scenarios on their own. It could be let's say inside Excel or even directly inside Xray if you're just writing those tests on your own. Some of the pain points that we typically see are teams are writing too many tests. They struggle with selecting the right tests for their efforts, leading to extended deadlines, more defects slipping through, and unknown, really just less confidence in the coverage that they're achieving. In addition, defects are slipping through into production with these outdated methods, leading to higher costs to fix them when, let's say, they slip into production or UAT just later down the line where they get a lot more expensive to address. We see a lack of agility because of all of this and a slower speed to market and also just difficult test automation. So these are some of the key struggles or pain points that we hear from our clients before they adopt the approaches that we're going to go through today. And the approaches that you're going to see today are meant to address these challenges head on and solve them for you. So with that, we've set the stage. We've talked a little bit about the tool that you'll see today and how it facilitates the approaches we're going to go through. Let's now get into the crux of the presentation here, which is what is model-based test design and how do we implement it? So talking about Test Case Designer and how it facilitates all of this, Here's what the overall process is that the bigger picture of how you can use the methods that you'll see today, as well as the tool, and fit it into your current processes and, pipelines. So, it all starts with Jira, with Test Case Designer and Xray, right? It's a plugin for Jira. And you analyze your system requirements and user stories there to then take your first steps in Test Case Designer. So, the first step based on your requirements analysis, you're going to define the parameters. We're going to spend time on this today. It's, a lot of the presentation, so you can see what I mean here. But those models of parameters that you're building are really those critical testing factors that are going to be then covered in the generated optimized test cases or scenarios that the tool is going to provide you. We'll emphasize all of this today again. You can then specify constraints, which are any impossible to test for interactions that should not show up in your test cases. We're, of course, then going to use the tool to generate optimized scenarios. We have detailed coverage reports available that allow you to view the exact coverage that's being achieved after running X number of those tests that have been generated for you. And then we have several output methods, whether it's syncing your scenarios back to Xray and Xray Enterprise, you can do that. Or we have also some export capabilities related to exporting skeletal code in different languages and frameworks. Let's say also generating scripts for robot, and just some other options as well. So that's the overall process here. For today's session, we're really going to focus on steps 1 and 4, defining the parameters model, taking this model-based approach to designing better tests, and then how the tool's algorithm can then facilitate generating these optimized scenarios based on these models that we build of parameters. So just wanted to set the stage there. We're going to focus on, again, steps 1 and 4 today, to show you how you can take better approaches to designing tests. So moving on, let's get right into what we mean by model-based test design. When we're thinking about the overall process of Xray Test Case Designer, kind of a reiteration of the last slide, but just to emphasize, what we're first going to focus on with this model-based approach is this step here, which is gathering your requirements, your business rules, your user stories, all of those sources of information that you're then going to use to extract out the critical testing factors and build out your model of parameters inside Test Case Designer. So we're going to focus on that step here. We're going to build a quick model together based on an intentionally very simplified hypothetical bank transfer application that I've made up. So let's get into it. So, really, I will say, as you're going to see today, really, the first step with these approaches is not just to start writing out scenarios. We're going to take a step back and first think about and build out what are just the collection of critical testing factors that need to then be included in those test cases that we're going to then generate. So we're not going to start writing tests immediately. And we're instead going to take that approach, take a step back and focus on this really critical step of defining these critical testing factors in general. There are going to be several types of key decisions that need to be made and questions that you need to ask yourself as you look into defining these parameters and values. And we're going to talk about that here. There's going to be some ideas at a high level that are not going to impact how your scope works or how your system under test works. They're not driving the end behavior of it. And those ideas are actually going to typically be left out of this general model of critical testing factors that we're building inside the tool. We can account for them elsewhere later on in the process. There are also going to be some ideas, though, that do impact the behavior of the system. And they are actually, when you're thinking about how to actually define them within this model that we're going to build, they're actually pretty straightforward in how you want to define them. These ideas might just, let's say, for lack of a better term, jump right off the page for you. And so we're going to include those ideas in our model because they're important to test in our test cases that we're then going to generate. There are also, although, going to be factors that do impact how the system works and how it behaves, but they're going to be a little less straightforward in how we actually define those ideas and include them in our parameters model. They're going to take more thought to design. And I like to show this warning to let everyone know that, especially for those ideas and others, let's pause for a moment and make sure we all understand we're actually going to have to use our brains in this step. We're going to have to analyze these requirements, these sources of information that have been handed to us, and think critically about how we want to extract the critical variation ideas within those to build out this model of parameters. At some point in the process, you are going to have to use your brain and your critical thinking skills to perform these steps. but that's a good thing, right? There are so many inherent benefits that come out of doing that. We're going to understand our requirements better. We're going to be having better conversations, let's say, with our business counterparts within our organization. Benefits come out of this step that we're going to talk about. So just keep all of that in mind. Let's move on here. So diving right into that first type of idea that you're going to come across when you're analyzing a system under test, analyzing your requirements, and so on. These are going to be ideas that do not ultimately impact how the system works. And if those factors truly do not impact the system in different ways, by varying in different ways, then we're not going to include them in our model. That's essentially what we're getting out here. There are different places inside Test Case Designer and later steps on in the process, let's say when we get to scripting, where you can add the less critical details that are still needed to perform execution. They're just not needed in this first initial critical step where we're just defining the critical ideas that by varying in different ways are driving the behavior of the system under test. Let's say in this example, this bank transfer application that you see on my screen here. So what's an example of this in this hypothetical UI that you're seeing here? Let's take the memo line, for example. This memo line and this aspect of the bank transfer app does not ultimately impact this monetary transfer, right? It does not matter what you put into this memo field. And because of that, the actual transfer will not be impacted by it or change in different ways depending on what you put there. So therefore, an idea like this, like memo, that is not impacting in different ways, we're just going to leave it outside of our parameters model. We're not going to do anything with it just yet in this first and most important step where we're just, again, defining the critical variation ideas. So we're going to leave that out of the model. These are ideas that you're going to come across that just do not impact critically how the system is behaving. You know, in this example, again, the memo line is not having a critical impact on that monetary bank transfer that's occurring, as opposed to some of these other ideas that we're going to talk about. So again, doesn't impact how the system works. We're going to leave it out of this parameter model that we're building. Second type of idea that we're going to come across is one that does ultimately impact how the system works. But not only that, these are factors that are also straightforward in how you want to include them as parameters and parameter values. So in this example, right, factors such as where we're transferring from, the from account, and where we're transferring to, the to account, and let's also say the frequency of the transfer are all absolutely definitely factors that impact how this system behaves. I'm not a banking expert, but let's just say I know based on my hypothetical subject matter expertise that these are critical to test for this bank transfer. It depends where you're transferring from. It depends where you're transferring to. Depends how many times we're performing this transfer, right? So we can check the box that we do need to include these ideas in some way, shape, or form in our parameters model. These are factors, again, that are ultimately affecting that transfer and how it's submitted. And so we want to include them inside Test Case Designer as our parameters model. And really, I should have probably mentioned this on the previous slide, but I like to tell users when you're analyzing whether or not a certain piece of your system belongs in this critical parameters model, there are really two questions you want to ask yourself that you want to be able to say yes to. Number one is this idea varying in different ways? If we go back to the last slide real quick, sure, memo is varying in different ways. You could put whatever value you want in there, right? However, you want to ask yourself the second question, which is, okay, it's varying in different ways, but by varying, is it ultimately impacting how the system works in different ways? If you can check yes to both of those boxes, it's going to make sense to include that idea inside your critical parameters model that we're building here in some way, shape, or form. On this slide here, these are ideas that, yes, are varying and are impacting how the system works. On this previous slide here, something like memo, sure, it's varying in different ways, but again, as we discussed, by varying in different ways, it's still not, though, impacting critically how that system behaves. So we're going to leave it out of the model. So just to recap there, those two questions are good to ask yourself. In this example, we are going to add these ideas that I've highlighted in Test Case Designer. And not only that, they're straightforward basically in how we want to define them. If we take the from account example, right, those ideas, you see the drop down list. It's pretty easy to tell what our variation ideas and our parameter values should be right there. Again, kind of jumping right off the page to us. So should be pretty easy in how we want to include those. Let's now open up Test Case Designer here for the first time and actually add some of these ideas there. So here's Jira, of course, and we've installed Xray, and we've installed the new Xray Enterprise plugin that it includes Test Case Designer. And you're going to see it here right on the left. And when you click on it, you're going to open up Test Case Designer. You'll get to some kind of quick dashboard there with your list of models and project folders and such. But I created a new model here. I gave it a name, Bank Transfer App. Our goal here, again, is to functionally test this hypothetical bank transfer application. And from there, really, we go ahead and take, again, this first and most important step, which is defining our parameters. So you do it right here on this screen. You have a couple different ways you can add them. One is just by adding a new parameter in this dialog box. For the sake of time here, to be honest, I've already written out the parameters and models, or sorry, the parameters and variation ideas here on another tab. So I'm just going to copy and paste them in here for the sake of time. So we have this text-based way that you can also add parameters and values. I'm going to utilize this to just paste in what we've seen before. But again, we're talking about ideas that have impacted how the system works, and they're varying in different ways. And so what we talked about, the from account, the to account, and the frequency parameters and ideas that we want to include in our parameters model. And again, they're straightforward in how we want to add them. We had our drop-down selections. We know what they should be, right? So let's go ahead and break this out into actual parameters and values. So the first one we had and second was from account and to account. I'm just going to paste them in, but the way that you define these is just kind of write out your parameter name, and inside the brackets, you have the different ways in which that parameter is varying, or better said, our parameter values, right? So you see these selections that came right from that drop-down list, right? And then I'm also going to add in the frequency. Now, in my hypothetical UI, I actually did not build out the drop-down list for frequency, but you can imagine what those ideas can be. And I've come up with, let's say, these variation ideas right here for this parameter. So we can transfer on a once, we can transfer on a weekly basis, every 2 weeks, and so on. Varying in different ways, impacting how the system works in different ways. It definitely is going to impact the transfer, whether you're transferring once, for example, or transferring weekly or bi-weekly and so on. So we want to include these ideas inside our model, and we've done that. And if I click save, you'll start to see that here. Okay, so that was our second type, impacts how the system works, straightforward in how we want to model them. Let's head back to the presentation here to look at the third type, which is, okay, we're going to come across some ideas that, yes, again, impact how the system works. They're varying in different ways, and by varying, they're impacting how the system works in different ways. So we check those boxes. We know we need to add it in some way, shape, or form. However, you're going to come across some ideas that are not as straightforward in how you actually want to define them as parameter values. They're not necessarily jumping off the page for us. So it's going to require some thought in how we actually want to model them inside our models and inside Test Case Designer. So checking it out here, right? If we look at, let's say, these examples, when are we sending the transfer? We got to put a date in there. And how much are we transferring, the amount? We could put whatever we'd like essentially within those fields, right? And how can we possibly know what to list out as parameter values? In general, inside Test Case Designer, the more parameter values you ultimately list out for certain parameters, the more test cases that are actually going to be generated for you. And for that reason alone, we need to be smart about how we want to define all of this, because a lot of times you could still get the critical coverage that you need without, let's say, just listing out a million different possibilities for the amount that we could potentially add in the field, right? Or the dates that we could fill out in the future. Let's think about how we actually want to model these in a smart way so that we're not generating too many tests ultimately and listing out too many values, and we're still getting the critical testing coverage that we need. So taking a look at these amount and send on ideas, I'm going to paste in what I came up with what should be those ideas there. You might be thinking about how you'd like to define them in your own way, given what we just mentioned. But we need to think of better ways to define these besides just listing out a bunch of random possibilities. So what I came up with for amount was, just pasting it in here, is this. Heading back to here. Let's take amount, for example. You see that all I did was list out three very kind of high level abstracted values: a small amount, a medium amount, and a large amount. So a common way essentially to, taking a step back, a common way to essentially, again, get the coverage that you need within your tests without listing out too many detailed parameter values and generating too many tests is to use this approach here. This is an example of it, what we call the equivalence class approach. In other words, essentially what this means, and what I've done here, is that I've grouped all the possibilities out there into meaningful groups and meaningful ways, or better said, essentially grouping parameter values together that behave in similar ways. And by creating meaningful groups and grouping values together that have the same ultimate impact on the underlying behavior of this system, we can still get the coverage that we need in our generated tests, again, without generating too many tests. So the way that I've defined this, right, is saying, essentially, it doesn't matter whether I choose, let's say a small amount is $2 amount and it's, goes all the way, let's say, to an $1,000 amount. Within that range, what I'm saying is that it essentially doesn't actually matter from a coverage perspective. I've deemed it this way that, and based on how I know the system works, that it doesn't matter what small amount you put in within that range. All it really matters from a coverage perspective is that we test the idea of a small amount with these other parameter values that we're building in our model. That's what actually matters here. So instead of listing out a bunch of individual amounts as parameter values, perhaps the approach could be just putting in these equivalence classes, which are small, medium, and large. Instead, let's say I could have actually, there are multiple ways I could have defined these equivalence classes based on, how the coverage that I want to achieve here. I could have instead, let's said, using this approach that I mentioned, I could have, let's say, grouped amounts together using actual numerical ranges, had like 0 to 1,000 and 1,001 to 5,000 and 5,001 to 10,000 and so on. Perhaps that's how I wanted to define these equivalence classes. It's the same principle at the end of the day. Again, grouping values together that have the same impact on the end behavior so that we get the coverage that we need without writing and generating too many tests. And again, it doesn't matter then which individual values we choose, let's say, between these groups or these ranges, they're all impacting the behavior of the system in the same way based on how I define this and my hypothetical subject matter expertise of how this system works, right? So that's what we meant here by kind of thinking about things in a smarter way. Instead of just, blindly listing out a bunch of different parameter values, let's actually think through the business rules here, the logic, how we know the system behaves when you choose certain values. And then perhaps a lot of times you're going to be able to use this equivalence class for, partitioning approach to just still get the coverage that you need in a manageable number of tests. So taking that other example, it was, when are we sending the transfer? We're going to use equivalence classes here instead of writing out a bunch of future dates, right? Let's just group things and say we have a today transfer. Perhaps we want to test that we can do one tomorrow and then some other future date. Of course, I could have broken this out differently and said like, something within the month, within 2 months, pick a date within 3 months and so on. That's just how I've done it. Perhaps I'd have a conversation with a business analyst. We might actually change how we do some of this. So I wanted to, give you all some approaches and how you can define all of these. Again, the goal here is to maximize coverage ultimately with the tool's algorithm once we build out this model and do so in as mathematically few tests as possible. And that's what the algorithm is going to do here. These are some approaches that you can use to start to build out this model in a smart way. So this is what we've defined so far. That was that third group, impacting the behavior in different ways while also thinking about how we actually need to define these ideas because they're not necessarily jumping right off the page. I could, of course, for this system under test, right, I could have multiple other aspects to this that you're not seeing on my screen here. There might be some environment factors we need to add, let's say, like what device are we using? What's the browser are we on? Just as some examples. Who's the account holders and the account operators? What was the account balance before transferring? There could be a number of other ideas that we use to build out this parameters model here. This is just meant to be a starter, right? One thing I'll just point out that's really cool within Test Case Designer too, as you build out the parameters model, we have this mind map view. Might seem simple, but it's really powerful because what you can do is as you're building this out, thinking through your requirements, you take it to, let's say, a business analyst and say, here's what I believe is critical to test. Here's how I'm thinking of testing those ideas. Can I please get your feedback? And as you get that feedback, you might determine that, hey, we need to add some other branches here, some other parameters, change the way in which we've defined some of these values and how we want to test these ideas. The cool thing is about this model-based approach inside the tool is you get that feedback and all you need to do is update your model essentially. Add some parameters here, change the way in which you've defined some of these. Those updates are then automatically reflected in your generated scenarios that will see your analysis reports and so on. So all of what you're seeing here is meant to be a time saver and it's meant to improve quality as well. And there's so many benefits that come out of that, right? Thought about those, we saw those challenges that a lot of people face. Hopefully you're starting to see how these approaches, and especially once we check out the scenario generation, how all of this is supposed to hit those challenges head on, right? So that's what this is all about, and how we build out these models of parameters based on requirements that have been handed to us and so on. So heading back to the presentation here, let's now focus on the next step here, which is generating optimized scenarios with Test Case Designer based off that parameters model that we defined. We'll also hopefully check out a couple other features just to point out real quick. So let's get into it here. So thinking about basically Test Case Designer and its algorithm takes a combinatorial approach and furthermore a pairwise approach to generating these tests for us based on the parameters model that we defined. So let's get into it here and talk about what we mean by combinatorial and what we mean by essentially combinatorial test design. So in a nutshell, it's a prioritization strategy that helps testers select the most efficient and effective tests for their system by really focusing in on the coverage of interactions between inputs or parameters and all the various different configurations there. Combinatorial efforts, though, can really be broken down into two main categories. There's pairwise testing and there's n-way testing. And let's take a look at what I mean by that. So why would you use combinatorial test design and combinatorial testing in general? The reason why is because these approaches really are far superior than others when it comes to designing just powerful tests for execution efforts. These approaches have really just been proven over the years. So, on one side of the spectrum, why would we, what are we not going to do? We're not going to try to test everything. That is not in our best interest. We're not going to catch more defects. It's been proven by doing that. And typically it would take lifetimes to technically test everything. So we're not going to do that. And on the other side of the spectrum, we're not going to just simply test everything once. This can lead to significant gaps in coverage and leaves plenty of critical system interactions left untouched that could very well trigger defects. So we're not going to do that. And instead, we're going to meet in the middle in the spectrum. And we're going to focus on covering all of the critical system interactions that typically trigger defects, that are known to have triggered defects. So we're going to use this simple mortgage application system under test just to get the points across here, just to illustrate why we cannot test everything. So right now, you're only seeing three pieces of the system listed here: property details, customer details, and loan details, right? Only three aspects. There's plenty more. So breaking down one of these pieces, there are three parameters associated with it, each with three parameter values. So within this one section alone, there are actually 27 possible tests that we could actually look at if we were to test everything, 3 times 3 times 3. Building upon that, though, looking at all three sections now, you may just be thinking that there are only 81 possible tests now if we were to test everything within here, 27 plus 27 plus 27. That is not the case, though. In order to get the total number of possible tests here, you actually need to multiply 27 times 27 times 27, which equals over 19,000 possible scenarios that we could look at if we were to test everything. That's a lot of tests to possibly run here for just a few aspects of this mortgage application process, right? So we are not going to try to write and execute every one of those, and there is a better approach that we can take. So what is this better approach? Again, it's the idea of combinatorial testing, or more specifically, pairwise testing. And over the years, it's really just been proven that through plenty of academic research that, and just practical application that, firms around the world, that, it's been proven that the majority of defects can really actually be triggered and are really caused by two types of interactions being accounted for in a given test. The first type is simply just one idea or parameter value or input being tested for that can trigger a defect. Sometimes that happens. However, taking it a step further, still within that majority group in purple, many defects are triggered by two ideas actually being tested against one another in a given test. We'll talk more about this in a moment here, but accounting for these two types of interactions is an excellent way to exercise the system under test and achieve thorough coverage without creating too many tests or trying to test everything. So as you can see in this diagram, defects caused by 3 inputs, 4 inputs, or 5, or so on are significantly more rare than 1 or 2 interactions being tested together and defects triggering that way. And again, we'll talk more about that. So the magnitude of the benefits that we're talking about here using these approaches it's been, studies have been conducted, and this one in for sure, has really proven that across 10 pilot projects at real global companies, they achieved some astounding results. Test execution efficiency dramatically increased. They were finding 2.4 times more bugs per tester hour than before. There were actually 13 more defects caught as well. And in addition, the time it took to select and document tests decreased by 36% using these approaches too. So you can see the magnitude of the benefits that we're talking about here by implementing these approaches. And we can kind of now see how the tool facilitates getting to this point and actually covering all of these interactions and what your options are. So let's jump into the tool real quick. Just to see what this looks like. So when we click the scenarios button, we, let's say, built out this model, right? This was very simplistic, but as we build it out, you click the scenarios button here, and within seconds, Test Case Designer generates optimized tests for us, as you can tell here. So in this example, the algorithm has generated 19 tests. These 19 tests are covering 100% of all possible two-way interactions within that model that we defined for this money transfer app. So furthermore, it's actually saying that within these 19 tests, there are actually 114 unique pairs of values that are being packed into just these 19 scenarios, which is really cool. So two-way interactions is the default coverage strength. And as we started to look at on the previous slides, it's an excellent way to achieve confident coverage and do so in a manageable number of tests. What we mean by two-way interactions is that we are going to, again, cover all of those possible pairs of interactions or groups of two parameter values. This is an example of one here. This is another example of one. This is another example of one. All of those possibilities are going to be packed into just 19 scenarios. There's exactly 114 of them. So each of these tests are as highly varied as possible that the algorithm has produced for us, by the way. The algorithm packs in as many of these net new two-way interactions as possible in each test. So the first tests are listed as covering many more new interactions than the final tests are down here. And because of this, these tests are meant to be executed in order, actually. So by packing in as much coverage as possible per test, by the time we get to these later tests, there's just not as many new interactions to still cover. We'll talk more about this eventually, but really, or you know what, I'm going to cover it now. What we call this is front loading these tests with coverage. So we're going to start off by packing in as many upfront as possible. By the time we get to the 19th test, there might just be one new interaction that we're still covering. So eventually there's this decreasing marginal return of executing additional tests because we covered so much upfront. And you can actually see that a little bit, starting to see it with this coverage graph here. This one's a little bit less dramatic than a lot of what we see, where it starts off steep and then starts to really level off. And start to see it kind of doing that here, but it's a good representation of what's actually happening here. Packing in as much coverage as possible. A lot of times this line's a lot more steep and then it really starts to level off because, again, of that decreasing marginal return of our efforts. Going back to the coverage strength options here, we talked about two-way. The majority of defects can really be triggered this way by counting for every parameter value once, every group of two parameter values once. But we do have options. I always tell users, right, have a reason to move away from two-way because it's an excellent way to get the coverage that you need in a manageable number of tests. But for whatever reason, you might say, I actually need to generate every three-way combination. Again, going back to that pie chart, you saw how much more rare three defects were, four-way defects, and so on. So I tell people, have a reason to move away from three-way. Maybe it's just a super risk prone application. I've heard it before, and you just want to play it safe and generate all three-way combinations. You can do that, but you see what that increase in our test case count gets to because we're covering so many more interactions here. But it's a more thorough way of testing. We can actually go all the way up to six-way. People don't do that. I will say it's super detailed. I hear maybe NASA will run six-way tests every once in a while for mission critical systems, but we give the options here, of course. There's some other options here that I won't necessarily get into as much today, such as let's say our mixed strength interactions. Here, essentially, you can actually be more thorough with some parameters and less thorough with others to kind of align well with risk-based efforts. So we give you all those options. But again, at the bottom line is here, we use the tool to first generate or create our parameters model. The tool will facilitate that step for us. thinking critically through the different ideas that matter. When we click then the scenarios button after we've built that model, automatically the tool generates these optimized test cases based off of that model for us. And these scenarios are meant to be covering a lot more and filling in gaps in coverage. And because they're as highly varied as possible, a lot of times that means we're going to be actually achieving more coverage with fewer scenarios. This tool is going to pack in as much coverage as possible in each of these tests, and it's going to generate 100% coverage of these interactions in quite literally as mathematically few tests as possible. So there's a lot we could cover with this tool here, like the constraints handling and those other steps that we saw in that process slide that I showed you. But for the sake of time here, that's really what I wanted to focus on today, taking a model-based first approach to test design, and then using the tool's algorithm to generate optimized scenarios for us. And from there, other steps, again, might be we add constraints. We invalidate certain interactions from ever showing up together in those scenarios if we need to. We can script out our scenarios actually using a Gherkin syntax and parameterize these steps, and then sync them back to Xray essentially if we wanted to. And we can also build out manual steps too. And with these capabilities, they're meant to be a time saver because what you're essentially doing, this is kind of a side note, but you're writing template scripts that are parameterized, pulling in the parameters from your model. And then essentially what it's going to look back, or what the tool is going to do is after you build out these template scripts, when you synchronize it back to Xray, it's going to take the one or a couple scripts that you've built and apply it to every single applicable optimized scenario that was generated for you in that table. And what it looks like eventually when you synchronize everything through the API back to Xray, it's going to generate an issue for each one of those scenarios and those sets of steps that you've built. So this is for a different scope, but you can kind of start to see what it looks like here. We wrote one template script, and then the tool generated a set of steps based off that template for every generated scenario here. So you're seeing what that looks like. Each of these issues is one of those optimized scenarios from Test Case Designer. These are the scripts that I had built out in the tool. The tool then applied it to every single scenario, generated all these here, and you're seeing what that looks like. And then you just continue on with all of, the Xray capabilities that are in place when it comes to reporting and collaboration and such from there and managing these tests. So starting to see what the workflow looks like here with Test Case Designer. The last thing I'll just mention is we have some analysis reports. You saw the graph. We also have the matrix, which allows you to view the exact coverage that's being achieved after running X number of those tests. So you're seeing after the first 12 tests where this slider is, we're already achieving 82% coverage. 13, you see a little bit more. Green squares have been covered after those 13 tests. Red squares have not been covered yet, but you'll see when they're first covered. And so the goal here is to just get smarter about our execution efforts using this graph and this matrix here to say, hey, maybe we can take on some risk and stop testing at a certain point, because just after generating the first 12 tests, we're already at 82% coverage. I can see exactly what I'd be missing if I stopped testing here. Maybe let's just say that we're comfortable with that and move on because we're under a time crunch. Making data-driven, smart, faster execution decisions. All of what you're seeing here, again, is meant to be a time saver when it comes to this test planning steps, and the benefits that come from, taking smarter approaches during this test planning phase trickle down to your execution and everything else, when it comes to releases. So it's important to highlight all of this so that you all can see, the goal here, model-based approach to designing tests, taking a combinatorial approach to allowing the tool to generate those scenarios for us when it comes to optimization. We're just getting more thorough, more efficient, smarter about this step in generating tests. And anytime really that you have a need to generate tests, I tell people, if you're able to extract variation ideas in some way, shape, or form, no matter what type of testing project you're working on, whatever the scope is, as long as you can extract variation ideas, this approach here is applicable. It's going to provide benefits. These parameter values can look however way you'd like. I see this being used for, let's say, API testing, where your parameter values look a lot different than just kind of this functional example here. So just want to state that this is all broadly applicable. And that's really what I wanted to cover when it comes to, using the tool to facilitate a model-based approach to designing tests, and also based off those models, facilitate and generate optimized scenarios for us that achieve more coverage with less. So just with the time that we have left, keeping an eye on the clock here, and being respectful of everyone's time. I did just want to point out a couple things about our new product, Xray Enterprise. So we talked about how Test Case Designer is actually incorporated within an Xray Enterprise purchase. It is one piece of a larger new feature set that we have. So I want to cover a couple other aspects of that feature set because it's really exciting. And just to cover really what Xray Enterprise is, we like to say, and it really is the next level of enterprise quality management. You're going to unlock quality with scale, speed, and efficiency with this additional Xray Enterprise purchase that is purchased on top of your normal Xray license. It's a new offering that we have. A couple benefits here. We talked about Test Case Designer and the coverage benefits there. We'll see in a moment here how you can actually trigger automation directly from Xray with the click of a button. So even non-technical folks can start to contribute to those efforts. And we've also added an enterprise support experience that there's a lot that comes with that, automatically included with an Xray Enterprise purchase too, because a lot of clients ask for that, and some additional support there. And with this offering, we can accommodate all of that. So, the goal here is to work faster, test less, cover more, deliver the highest quality possible. We've built Xray Enterprise specifically to address those things and adopt some of these approaches just on a greater scale in general. So that's what Xray Enterprise is all about as a whole. Again, Test Case Designer is one of the features within there. We've got a couple others listed here: cross-project reporting, remote jobs triggering, the enterprise support I mentioned, see the benefits there, dynamic test plans. We're eventually going to release the ability to manage test environments better with Xray. You can now create multiple versions of tests with Xray Enterprise. And we're also going to be adding some safety-focused project reporting capabilities as well to just kind of increase the alignment and collaboration at scale. That's what this Xray Enterprise is all about, right? So just to show a couple of the other features real quick, we do have, for example, I'm going to cover, I think just for the sake of time, a couple of these that are important: cross-project reporting, remote jobs triggering, and test case versioning. Let's focus on those today. And again, we offer trials. I'll talk more about that, but you can get access to everything that's available here inside your own kind of Jira license and try it out for yourself. So covering a couple other of those features though, right? Let's first just quickly show the remote jobs triggering. Again, we talked about Xray Test Case Designer that comes with Xray Enterprise. The next one, again, remote jobs triggering, something that will be included when you install Xray Enterprise. So when you go to project settings, you're going to see this remote jobs trigger here, this new option, and it allows you to create these triggers for these different configurations and applications and builds, right? So we have available right now compatibility with Jenkins, Bamboo, GitHub, GitLab, and Azure DevOps. If there are requests for others, we'll consider adding more, but this is what we started out with. And essentially what you're going to do is just anytime you want to configure one of these, you enable it and you add a configuration. I've already done one here a while back. I'm not going to show it fully run today, although it just takes a couple seconds. For the sake of time, I just want to show you that you can configure these. You give it a name, you identify what the job name is, the token is, your username, and so on. And eventually, within tests, you're going to have the ability instead to just trigger this remote job. It's going to pull up Jenkins and just run that build for you and that configuration for you automatically with the push of a button inside Xray. So we have that in place now to just kind of speed up the process and allow others to contribute to these efforts as well. So I wanted to just introduce you to that new feature that we have. A couple others that we have is the cross-project reports. So within Xray reports now, before you could only kind of view the results and metrics for one project. Now with Xray Enterprise, when we talk about the theme of adopting all of this at scale, we have the ability for you now, as you've seen I've already done, add multiple projects to the same report, kind of get this higher level visibility and broad visibility of results across multiple projects, which is really neat. So when you generate the report here, you're going to see that we now have all these projects included within this report, again, which is really cool. For some organizations, this kind of higher level visibility is really important. So we wanted to incorporate that into Xray Enterprise, again, along those themes of scalability. And it was a highly requested feature, so I'm glad we were able to implement it. Last one that I'll just show today for the sake of time is the test case versioning. Again, we have some other features that you saw on my screen there. We're adding some. We're going to continue to build out Xray Enterprise more. But just to show you real quick the test case versioning, this was another highly requested feature inside Xray, so we've incorporated it into the Xray Enterprise purchase. So within any issue now in test, you're going to see here that you have versions. You can at any point just add a new version. You give it a name. I'm just going to duplicate and copy from version 1, but allows you to have multiple versions of the same test. So you might want to change a couple aspects of the tests, a couple of the steps, insert some different data. You can do all of that now without just creating multiple of the same tests, which is really nice. We now just have versions within them. So that's what Xray Enterprise is all about. Again, along the themes of delivering higher quality software, achieving more coverage, all with less, with higher speed. We've aligned these features to do all of that, including Xray Test Case Designer, which is one of those premier features of Xray Enterprise. I think hopefully by the end of this, you've started to see how, putting the tool aside even, you can just take better, smarter, faster approaches to test case design using the model-based approach. And then if you'd like, use a tool to generate scenarios for you based off those models that you're building. There's a lot more that I could have shown today, but I hope this started to introduce you to those approaches. I think now we can just hand it over to Q&A, and then we'll just kind of finish up with how you can get in touch with us. So I hope you all found this beneficial. Happy to open it up for questions now.